Hello everyone, and this is how I'm doing this recording and to make a kind of a video tutorial for all of you. And some of the students in the afternoon session, they asked me to make this video because they think this may be much better than just a tutorial, because you can look at what I use, all the functions, and also you can always pause and slow down when you watch the video. And also I think this is good for me because I don't need to write down everything. I just need to mention. So, and if you open the map, okay, in this one I do not have the output group layers you see here, but I just have the starter. But when you do it by yourself, you can always use the output layers to check your results. And in the last session, what we were doing is to do the hazard analysis and the land cover changes analysis. And for the first one, what we used is 100YFloodPlain and wildfire data. And I think I mentioned these two data sets in the first class and also in the last session, last lab session. So I will not explain to you what the data are. So when you open the map, first I need you to just turn on the master boundary and the building and 100YFloodPlain. So first thing we need to do is to look at, in this region, how many of the buildings within the 100-year floodplain. And in this case, 100-year floodplain is the hazard area, and that means the high risk. The floodplain will happen in those areas. So the first thing we need to do is to use select by location. Go to selection and the select by location. In the target layer, we should use the building layer, and there's the south layer here. This is the one we need to use to select all the buildings. I think most of you in the ArcGIS class, you already use the select attribute by attributes. That is just one basic function in ArcGIS. But sometimes we need to select some features based on the spatial relationship, and this is what we need to use, is select by location. And we just choose 100-year floodplain, and in this drop-down list you will see a lot of spatial relationships. You can always play around with all of them using your own data, but in this case I will just use this intersect, not this one, intersect the south layer, because we want to look at all the buildings and intersect with 100-year flood. It's not necessary to look at all the buildings totally within the 100-year floodplain, and we just want to look at all the buildings intersect with 100-year floodplain. Okay, just click OK. Just wait a moment, because I use this data on my own laptop and maybe run a little bit slower than lab's computer. You see, when you finish that, you will find some of the building has been highlighted, and the next step is just export those buildings to a new layer, because it's always good to run all the functions on the target layer instead of using selection. It's just a good habit to just export everything you think is useful information to a separated layer. So go to data and export data. Select features, and then you just choose somewhere you think is good for you. In this case, I will just go to, maybe I just create a new one. Walking. It's okay. You can save anywhere you want. Walking. And please use shapefile, because you save some you save the geographic layers in a folder instead of a geodatabase, so you should use the shapefile here. Okay, it's building and 100-year floodplain. Okay, It's okay, you always save another name. Okay, do you want to add? Yes. Add this one. You can drag this to under this group, what we call the header editor. You don't need to do this. It's just I usually just organize all the files I just created. You see here, I always organize them. Okay, so now I think you don't need the building file because you already create a new file to represent those buildings within 100YFloodPlain. So you can feel free to turn off this layer, but before you do that, please make sure you unselect all the features within this layer. So just choose this layer, building layer, and unselect. Okay. So all of those buildings within 100YFloodPlain has been unhighlighted in this map. Now you can safely turn off those buildings, but you can still see some buildings within. I can zoom on. I can zoom the screen. You see here, you can see still some of the building has been created. This is the new layer you just created. And sometimes it's very hard to tell, so now you need to change the symbology. This is what I always use, this one, to change the symbology to make those buildings much easier to show up in the map. Okay, so now you see all the buildings within the headed area has been highlighted. The next step, so now we know all the buildings, all the locations. If we open the attribute table, just right click, single click, right click, open attribute table. You see in the building shape file, there almost no information here. You can see this two column is just the basic zoning. It's not very useful because we do not have other informations. One thing we want to look at is how large of those areas are, and if we want to, in order to do that, we need to add a new field. We can call it square footage, and you can save it as a long integer or double. It's okay because I do not want the decimals. I just save it a long integer. Now you just create a new field in the building layer. Now you can calculate. You see here, right click, you will find one thing called field calculator, and the other one is calculate the geometry. What we need to use for this one is to calculate the geometry, and the property is area. You can see you have always calculate other things, but in this case I will just use area, and the coordinate looks fine, and the units I will just use square footage. Okay, now you see all the square footage has been calculated. Then one thing you can get from this layer is to get a summary of the total square footage of all the buildings within the 100YFloodPlain. And you can just also right click the single square footage field. There's one called statistics. Okay, now you can get the statistics. It's kind of a rough summary of the for one field. In this case, what we need to look at is the sum. Sum means total square footage of the buildings within the 100YFloodPlain. You can also do the same thing for the building layer. By doing that, you can calculate the total building square footage within this whole area. Then you can compare this sum with that total square footage, and you can get something like the percentage of the buildings within HazardArea. You can get that information. And in this case, because I want to decrease the video size. I don't want to take use too many time, spend too many time on this. I just want to show you what we can use of this data. So when you go to the summary, you get this number. You can write down or just enter this in Excel. You can just do the same thing for the whole building layer. You can also calculate the total square footage, and then you can get the percentage of the building within the 100-year floodplain. Okay. So for now, we already know which buildings are within the 100-year floodplain. The next question is who live in those buildings? Because if you open the table, there are no such information here. So what we need to do is to get those information from the Census Bureau. We can use the Social Explorer or the Census Fact Finder to download the data. I already download data for you. If you turn on the blocks now, blocks, and you can check the all the information here. In this case, I have the racial information, like the percentage of white people, Hispanic people, black people, Asian people, and the total population. Some cases, when you use the geographic information, they just have the some kind of limited information saved in that geographic layer. And when you download other layers, in this case, if you think those information is not enough, you can always download other data from Census Bureau or Social Explorer, and just make sure you use exactly the same geographic unit. In this case, it's blocks. So if you go to the table of contents and you choose list by styles, you'll find there's one table here, and also add this table to this map file. So if you open this table, okay, sometimes it just goes very slow. Okay, you'll find this is kind of the information. This is the new data about all the age information, median age. I download this from Census Bureau, and you can see this JID refers to the block ID. So I can use this block ID to build the connection between this table and the blocks file. And then the next step, I can transfer the information in this census age table. This census age table, transfer the information to the blocks layer. Okay, so for now, I want to first open the attribute table before I transfer the information from the census age table. The first I need to do is add a new field in this layer. I can call it age for all people. Just give you an example, and this should be the long age. Okay, long age or double, it's okay. I can just use long age. So now you think all the information has not been coded. The next step is to join this blocks layer with the block census data. Okay, just go to the table options on the top left, and you can choose the join and relate and join. Then you can join it. In this case, it's using this table, and the blocks we choose the GLID 10, and you see here the GID has automatically been set up. So keep all records is okay, and then we just keep all records and click OK. Okay, so now you can also check. You see the GID exactly the same as the GLID here. Okay. So next step is to transfer the information from this field and to this field. Why we need to do that? because we do not want to always use this kind of joint view. We always to want to get information from one reference layer and to your working layer. In this case, the working layer is blocks, because you do not want to just use this joint view. It will make the ArcGIS work very slow. So in this case, we'll just choose edge, or you just add it in the last step, and then you can choose the field calculator, and in this panel you will choose, you see here, if you have exactly the same name, that will add the layer name in the front of the field name. In this case, we will choose the block sensors edge dot edge, or this layer. We should choose this layer to copy all the information from this table to the block layer. Okay, just a second. You'll get all the edge information has been transferred. Okay, I do not want to see this. Okay, I think if you use lab's computer, uh, it will run much faster than mine. Okay. Okay. Now you get all the information coded in this layer. So now you don't need to rely on this joint view. You can safely remove the join. I think I always to use join, and after you get the information you need, always remove the join, because you do not want just to work on something like the joint view. Is not a good habit. Okay, now you get what you want from one table. You can now just remove all joins. You see here, even if you remove the join, the information is still saved in this working layer. So now we kind of we get all the census information we need. We want to look at the demographic information. The next step is to kind of transfer this information to the building layer within that 100-year hazard plan. You see here. But the difficult thing is, the last time when we transfer the census information from this table, we use this GL ID, this kind of a common ID for the two tables, so we can use as the key ID to build the join or build the connection. But if we open the building 100YFloodPlain, if we open this layer, we found there no GL ID here. This ID is just a unique ID, does not have any it does not mean any kind of geographic unit or something. It's just a unique ID. We cannot use this one. So next step we need to use is the special join. I think in your ArcGIS you already learned a lot about the basic join, but you may not have any experience on the special join. But special join is very useful for all your tasks in the future. That's the major reason why we use ArcGIS, because we can always transfer information from, among different layers based on the special relationship. That is why we use special join. So go to the building 100-year floodplain. First open the table. The same as blocks. Now we want to transfer some information from other layers. Before we do that, we always add a new layer and call it HR. By doing the special layer, by doing the special join, you do not need to add field. I just forget that. If you want to do the special join, you do not need to add all the necessary field before you do the join, because the special join will create a new shape file with all the information from both the working layer and the reference layer. So you do not need to add any layer here. Let's go to the table options. and also go to this join and relates and select join. But this time you should choose the second option here. Join data from another layer based on the special relationship, special location. Many of you may not know there is another option here, but now you know this, and this is very useful for the urban planners. And choose the blocks as the reference layer, and you can read all the information here about the difference between these two options. Usually I will choose the second one. The first one is something like if there are two there is one buildings, they just have some part of the buildings in one block and some part of the building in another blocks. For that case, if you choose the first option, that will just calculate something like the average of the information from both blocks and transfer that information to the building. And the second option is something like we just use the nearest blocks information. This is the one I always use because sometimes it's very hard to use this aggregation method. And you can just copy the information from the nearest blocks. I think it's just a good estimate for your purpose. And choose the output. Well, okay, layer. Can call this with sensors. It's okay, you can name it as whatever you want. Sensors, I don't know what to. That's this right. Just wait a second. You see here, a new layer just added to this layer. Okay. Also, you see, you also want to highlight those new created buildings. You can use the same symbology as the one you just created last time. You can use exactly the same symbology. In this case, just right click this layer and go to the properties and go to symbology, and there is one called import, and you can import this one, the building 100-year floodplain. Not this one, 100-year floodplain. You see here, when you choose that will copy exactly the symbology definition to this new layer you just created. Okay. By doing this, at this step you cannot see any change, but if you turn off the one you previously created, you see here, the new layer has exactly the shape, the building shape as the previous one. But if you look at the sorry, in some case, where's one real floodplain? It's just sometimes it's just not showing in this table. It's okay. Okay, now you can open this one. Looking at the table. Now all the information of the from the census bureau has been copied here. You see here, white percentage, Hispanic percentage, black percentage, Asian percentage, population, and the age information now has transferred to this building layer. So you have much more information to show. First, the square footage, we already showed that before earlier. And now I want to use one case study to show you why we need those information and how you can use information to do any analysis. So what I want to use is this. You see here, there's some of the buildings here and the layout of the buildings within the 100-year floodplain. And before I select those buildings, I want you to go to the table of contents. There's one called list by selection. because I want to select some features in this layer, and I do not want to interrupt with other layers, because sometimes when you select something, you also select the features in other layers. This is something you always did in ArcGIS. So I do not want to do that. I need to make all the other layers unselectable. You see here, when you click this will turn to the black and white. That means this is inactive. I just make sure this building 100YFloodPlain with this layer active is selectable. That means selectable. And then I go to the select features. Okay, it's just on the top. Select features. You can choose select by rectangle. Okay, if you are not sure, you can always do the zoom first. Okay, and then you can do the selection. Okay, I want to do the selection. You see, just the buildings have been selected instead of all the features. And also you can always go to the whole region. You see those selected feature has been highlighted. Okay, now I want to summarize some information from this. This look at those buildings are within one neighborhood, but you see here a lot of them within the 100-year flood plan. That means hazard. Those buildings are under risk of the flood. So if you go to the attribute table, see here, I do not want to show all the records. I do not want to summarize for all the records. I just want to summarize, to do the summarize for those selected records. So I need to switch to this one to show the selected records. Okay, and now you can just scroll down and to look at the to give you a big picture of the demographic of those buildings, of the people within living in those buildings. The next step, for example, if we want to do some environmental justice analysis, we want to look at how many Hispanic people living in this hazard area. We can just select this field and right click and to go to the statistic. Now you see here, the mean value, the average value is 0.54. That means just for those buildings, it's about 54% of the people living there are Hispanic people. This just gives you an estimate, because we use the blocks data to do the estimate for all the buildings. So those numbers are not equals to, exactly the real, the status of for that building. For example, this 45 does not mean for this building there are 45 people Hispanic and 54 people white people. This just give you a average for the people living in the same neighborhood. So now you get that in that specific case study, for this specific case study, in the studied site, 54% of people are Hispanic people. The next step is we may also want to compare this value with the total average. And if we go to the blocks, we can always look at this one, Hispanic percentage. We can also do the same thing for all the blocks. So the mean value is 13.35. That means on average for the whole region, The average Hispanic people about 13.5%. 13.5% people are Hispanic people. So if from the environmental justice standpoint, you may say that um, just the Hispanic people, why those Hispanic people living in the hazard area? Is there any environmental justice issues? And also, in this case, I just use the racial information and the age information. You can always use other information like property values, like Bob just mentioned in the class. You can also get the property value data from the city of Leander or Campbell or somewhere else. And in the parcel data, you can look at the property values, land value, market value, or something. You can look at you can calculate the estimated values. I mean, on the risk. That is also a good research. And also, you can just get the income information, but the income information is not good for blocks. The smallest unit for the smallest unit for the income is block group or tracts. So if you want to use the income data, you may not use the larger geographic unit. Okay, anyway, I just want to show you an example of how you do the hazard analysis using the 100-year floodplain. Okay.